What's up, everybody? Welcome to Coding with Chaim. In this week's video, we're going to be taking a look at building a serverless REST API using AWS Lambda. So really quickly, let's just talk about what serverless is. And so the analogy that I think really sunk in for me, that really helped me kind of grasp the concept of serverless, was basically a tweet that I saw from a guy named Kelsey Hightower. And I'm going to leave the tweet up on screen so that you can see it as well, because I won't be quoting it directly, more or less just paraphrasing it. And it goes a little something like this. He used to basically always play video games on the PC, which of course meant having to make sure that he always has the latest and the greatest hardware to be able to play the games at their best resolutions and their best settings, right? So you have to upgrade your processing power or your RAM or your graphics card. And there's just a lot of kind of work on you as a gamer to make sure that you have what you need to be able to play the games at their best settings. Eventually he sold out, in his own words, and then went ahead and bought himself an Xbox, because now all he has to do is buy the game, install it, and just play. It just works. That's serverless. The idea basically being that we, of course, as developers can just focus on writing our business logic. We can just focus on our projects, focus on the fun stuff, and everything else that's involved with sort of deploying and maintaining a full-scale application gets handled for us by our cloud provider. That's the kind of basic idea. Just play the game, just write the code, just have your fun. Don't worry about all the other stuff. So to that end, what we're going to be doing now is we're going to be using AWS Lambda with a framework called the Serverless Framework to actually go ahead and build a very simple CRUD REST API. Basically, we're going to be having a DynamoDB table that's going to be managing cars. We're going to have all the basic CRUD operations. That is, we're going to be able to create, read, update, and delete a car within our DynamoDB. And of course, all this is going to be happening via AWS Lambda functions. And what's going to be sitting in front of our functions is, of course, going to be API gateway. So just to kind of touch on that point really quickly, when we say that we're going to be writing a serverless REST API, of course, the whole word serverless is kind of a fallacy. There is no such real concept of serverless. The main point is that we won't have to be worried about provisioning a server, and we're not going to have to worry about any of the sort of complexity that comes with having to manage a server. But that's not to say that there is no actual server involved, right? The basic idea is that with AWS Lambda functions, right, you can set up a different type of trigger, that's what it's called, to sort of invoke that function. And you have a different, a list of different types of triggers that might be. You can have an HTTP trigger, you can have a timer trigger, I think a rate trigger, you can have a socket trigger, you could have triggers that are going to be tied to specific events, like say a CloudWatch alarm or something like that, right? But the idea here is that since we're going to be building a REST API, we're going to make our functions actually get invoked based off of an HTTP trigger, which of course means that there's going to be some kind of server that's going to be able to handle that incoming request and then invoke our function for us. And that's exactly what API Gateway is going to be. So we're basically going to also have to configure API Gateway to be able to actually listen out for the incoming routes that are going to be sent from some client. Like somebody might be like either in Postman, which is what we're going to be using, or let's say you're building a simple React application that has to communicate with your backend. So you're going to be making simple actual requests, HTTP requests, as some kind of URL that's going to be generated for you by AWS, which is going to go to API Gateway. And then your job is to then tell API Gateway which one of your functions to actually go ahead and invoke. All this might sound like it's a lot more complicated than it actually is, because as it turns out, using this aforementioned serverless framework that we're going to be using together, this becomes a lot easier to manage. So let's actually quickly take a look at what it is to actually what it takes to actually go ahead and set up the serverless framework. So as you can see, I'm here on the Serverless Framework's website, and the one thing that you're first going to want to do, of course, is make sure that you have it installed. If you're on a Mac, you can either do it this way. If you're on Windows, you can do it this way. Personally, I just did npm install -g. That's just the way that I installed it, but you can do whatever you want. It doesn't really matter. Finally, the other thing that you're going to have to do is you're going to have to actually go ahead and run the serverless command. So just open up your terminal after you're done installing it, run the serverless command, and then it'll just kind of go through a bunch of prompts for you. And you might actually have to also create an account with serverless. Don't worry, there's a free account. You don't have to worry about that. And of course, we're also in this video going to be using AWS. So if you don't already have an AWS account, they'll also prompt you to kind of get that set up. So very straightforward. They tell you exactly what they want throughout their prompts. It should only take about a minute or two, and then you'll be good to go to actually start using the serverless framework to actually go ahead and scaffold a new project. Once you're actually done with that, the next step that we're going to do is open up our terminal, and we're going to simply run the serverless command again. So I know you just ran this command to kind of go through the configuration, but once you're done with that initial configuration, you can also use the same command to actually go ahead and scaffold a new project, and that's exactly what I'm going to be doing right now. So I'm going to run the serverless command. It's going to tell me that there's no project detected. Would I like to go ahead and create a new project? I'm going to say yes, I do. I do want to create a new project. It's going to be an AWS Node.js project. We're going to go ahead and call this project the Cars REST API. And it's also asked me if I want to add some monitoring and stuff like that. So for now, I'm just going to go ahead and say no, don't want to complicate anything, and then we're done. The project is officially created. We now have a new folder called Cars REST API, which we can cd into, and then we can go ahead and open that folder in our editor of choice. Of course, for me, that's going to be VS Code. So I'm going to say code dot and open this folder in VS Code. Okay, so as you'll notice, we have 3 files. We have the gitignore, we have something called handler.js, and then we have the serverless.yaml file. So let's, of course, first take a look at the serverless.yaml file. And basically, this is where you define all of the configuration for your service. So basically, you're not creating a service. Let's say in our case, we're building a service that's going to be handling these sort of CRUD operations on a cars table. That is the service that we are creating. So as you can see, the name of the service here is going to be Cars REST API. We're going to be saying that our provider is going to be AWS. The runtime will be Node 12. And then we just have to make sure that we can always use the latest available runtime that our cloud provider supports. I'm not quite sure at this moment what AWS supports, so for now I'm just going to leave it at Node.js 12, which I know obviously that AWS does support that, so we can just leave it at that. And then there's a lot of kind of commented out code here, which you can pretty much just look through to kind of get an idea of what are some of the things that you can do. It's kind of helpful to get a basic idea. But the thing that's going to be most important for us right now is to come on down to this functions section, and we'll notice that what it's basically saying is we're going to have a function called hello, that's going to have a handler that you will find in the handler file. So if you remember, we had a file called handler.js, and it's looking for something called the hello. So effectively, we're looking into the handler file, looking for a function called hello. So if we go onto the handler file, we'll see that we actually are exporting something called hello, which is nothing more than a function that's going to be receiving this event as an argument. And then what it's going to do is very simply go ahead and return this body that has this message, and then the input, which is the original event that came in. And then we're just going to do JSON string if I want to actually get that to be JSON to be able to send it back as a JSON response to whoever's calling it. But the one thing that is not currently specified is what kind of endpoint or what kind of method and which endpoint do we need to use in order to invoke this function? Because remember, as I said earlier, functions can be invoked based on different events. So of course, in our example, we want to make sure that we're going to be using the HTTP trigger. But to simply say that it's going to be an HTTP trigger won't be enough, because now we have to specify, okay, which method is it a get, a put, a post, a patch, whatever it is, and also which endpoint. Are we going to go to /foo, /bar, /baz, whatever it is? We have to make sure we tell API gateway, and this is exactly what I'm talking about. In this file, we can very simply configure that to be able to tell API gateway that if you ever get a post request to this endpoint, this here is the function that I want you to go ahead and create. Okay, so now as you'll see, I've uncommented another section here in the serverless.yaml file. So we're under the hello function. We've specified what its handler is. Now we want to specify which events are going to be invoking this function. So we have this events property uncommented. And now we're saying that we're going to have an HTTP trigger. Now, in order to trigger this HTTP event, we have to now also tell it which path and which method to use to go ahead and invoke this particular function. So we're saying that we're going to have an HTTP trigger. The path is going to be users/create, and then the method is going to be a get. Of course, it doesn't really make much sense, but this is how they had it in their example. So I'm just uncommenting it for now. And then this is going to be the simple example to kind of show you how we can actually go ahead and invoke this function based on the API gateway URL that's going to be given to us once we actually go ahead and deploy this project. So that brings me up to the concept of deploying. In order to actually be able to run this application against your actual API gateway URL, what you now need to do is you simply need to deploy the application. The way to do that is to simply say SLS. So instead of having to say serverless, we could just say SLS to shorthand the serverless keyword. And then the command that we want to use is going to very simply be deploy. So we're going to go ahead and run this. And this will take a little bit longer as the first time you're deploying it. So don't worry if it takes like longer than you're expecting. It's totally okay. And also serverless gives you some pretty good output of whether or not you've had any errors. But assuming you won't have any errors, you're going to get like a nice output telling you what the actual URL is, which methods you can use to go ahead and invoke that URL, and they can go run it in Postman. So I'm going to run the deploy command now. I'll be back once it's actually done deploying. Okay, so as you can see, it is now done deploying, and here you'll see we have a get to this particular endpoint right over here. We're going to this gibberish execute API US East Amazon AWS.com /dev/user/create. So this is the actual users create endpoint that we ourselves specified in our YAML file. Here is the get that we specified. All the rest has been generated for us by API Gateway. And so now we can go grab this URL, open up Postman, and see whether or not it actually works. Okay, so here I am now in Postman. I have a get request, and I've specified the exact URL that I just copied from my terminal. Let's go ahead and send the command, send the request, and as you can see, we now do in fact get back the response. The message is going to be equal to go serverless, and then the input is going to be whatever the event actually was. And there you have it. We now have basically built a simple AWS Lambda function that lives on our actual AWS console or in the AWS cloud. We have an API gateway sitting in front of it, and we can actually go ahead and invoke it using a simple GET request to the desired endpoint. But of course, that's not the scope of this video. We want to now take this exact concept and go a step further and actually start building a real REST API. Now, here's the one thing that's also going to be quite cool about what we're going to be doing together is we're actually going to be using Express. So if you come back to the code, you'll notice that this here is a little bit wonky looking code. You're not really, especially if you've written any kind of, Happy or Koa or Express, if you've done any kind of building up a REST API in a Node environment, this doesn't seem very familiar to you, because the whole concept of you having to actually build up your body by JSON stringifying it, and even more so if you actually make a post request to this endpoint, if you want to read the body out of it, you have to JSON parse it yourself. You might not be very used to this, because typically most of the frameworks that we use in Node kind of handle this for us, whether you be using body parser with Express, or I think Happy just handle this for you automatically. Regardless, this is not very comfortable. So what we're going to do is we're going to try to make this look like a regular Express API. In fact, from the person who is not aware of the fact that this is actually running on serverless infrastructure, would never know the difference that this isn't a simple Express server that we have built in Node. They would never know the difference, and that's exactly what we're going to be doing right now. So in order to make that happen, there's a few things we're going to have to install really quickly. So let's bring our terminal back up, and we're going to want to install Express, of course, but then the sort of magic sauce comes from us installing this thing called serverless-http. So let's go ahead and hit enter, install that, and then we'll see how we get this all configured, and then start building our actual REST API. Okay, so now that that's done installing, let's start configuring this to be able to write an Express API using AWS Lambda. Check it out. Okay, so coming back into our serverless YAML file, you'll notice that it looks a little bit differently, but really all I've done so far is I've gotten rid of all the comments, and then I did make one small change or a few minor changes in regards to our actual function. So the function is now no longer called hello, it's now called app. The handler is now no longer referencing handler.hello, it's now referencing handler.app, but now the main thing that I want to draw your attention to is that under events, I'm still specifying the fact that the trigger is going to be an HTTP trigger, but this is where things start to get interesting. I'm basically configuring API Gateway to know that any method is okay, no matter what, whether it's a get, a put, a post, a patch, it doesn't make a difference. Any method is fine. And then we're telling it to proxy plus. Basically, proxy plus is a way of telling API Gateway, no matter which endpoint you get, I want you to proxy off this request. So now what's happening is we are pretty much going to be specifying a function that's going to get invoked no matter which one of these particular endpoints is going to get hit. No matter what endpoint API Gateway gets, it's going to go in and be invoking the same AWS Lambda function, and within that function, we're now going to have sort of different forks in our code with Express. Pretty much we're going to be defining a bunch of Express endpoints, and then each one of the corresponding endpoints from Express is going to get called based on whichever endpoint API Gateway is proxying off to us. And the cool thing about this is all this is going to be happening serverless within an AWS Lambda function. So let's start writing the actual code with Express right now, because the serverless configuration as of now is done. Okay, so let's take a look at what I've done so far. As you can see, we've installed the serverless module, the serverless HTTP module. So I've gone ahead and I've imported that here, or required that here. Then I'm simply importing Express like you normally would. I'm creating an app object by calling the Express function. And now here's where things are a little bit different. This is the one and only thing that's going to look a little bit different than a typical Express application. And that is here I'm saying module.exports.app is going to be equal to serverless passing an app. So whatever this serverless function is going to be returning by accepting the app as an argument, that's what we're going to be attaching to this module.exports.app, which, as you remember, is exactly what we're referencing here instead of our YAML file. So basically we have a function called app. The handler is referencing the handler file's app function. So if we see that the app function here is exactly what serverless is going to be returning. And that's basically how serverless can pretty much grab whatever endpoint is being passed on from API Gateway to itself, and then take that and proxy it off further to our actual Express endpoints that we're going to be specifying right now. So let's start with a simple basic GET request that we can now just see and test the concept of whether or not we can actually start using Express with the API Gateway. So we have an app.get now, which is going to be going to /test, and then all we're doing is we're just returning a status code of 200, and then just returning a simple JSON object with the key foo, whose value is going to be equal to bar. So let's once again go ahead and deploy this, and then see if we can actually go ahead and invoke this very endpoint from Postman using our API Gateway URL. So let's try that now. Okay, it's done deploying, so let's go ahead and take this URL. So now we see we have an endpoint of any method, and then the URL pretty much goes to /dev/proxy plus, which basically means that we have to always make sure that we include this part. Then here we can put in whatever makes sense for our actual Express application, because API Gateway at that point doesn't care anymore. It's going to take whatever you pass it and send it onwards. So now we just have to look at whatever we have specified in our own Express application, and then based on that, go ahead and append that. So that means in this case, we're going to take this entire URL, and then here we're just going to go ahead and pass along test, because that was the endpoint that we specified right over here. So let's try that. Okay, so we're back in Postman. Let's just paste in the URL that we just copied from the terminal. I'm going to write test right over here, hit enter, run it. And as you can see, we do in fact get foo is equal to bar, which means that we've now effectively actually made an API Gateway request go to our Lambda function, which has then been handled by actual Express. Very cool stuff. So now we can finally start building our actual REST API using DynamoDB to handle the basic CRUD operations on our cars table. Okay, so now since we're going to be using DynamoDB, we of course need to make sure that Serverless is going to be provisioning for us a DynamoDB table for us to kind of be able to get to work with. So there's a few more things that I've now added to our serverless YAML file to kind of get this configuration to work. So let me walk you through what I've done, and then we can actually start writing the Express code to kind of go along with it. Okay, so here you can see that under the runtime or under the provider runtime, we are now specifying Iam Role Statements, which basically means that there's going to be an Iam user that serverless is going to be using to kind of do all of these actions on behalf of this particular project. And so what we're pretty much wanting, we want to just give it permissions to be able to do anything in DynamoDB. So what we're basically saying is that we're going to give it the effective allow on the action is going to be DynamoDB star, pretty much any DynamoDB action that you want, enter in any resource. So really the truth of the matter is, once you give resource star, you probably don't even have to specify the action. So this wouldn't really be production ready code. This is mostly just for the sake of this tutorial. If you'd want to actually do this in a more production ready environment, you'd want to look through some of the CloudFormation scripts and documentation for setting up IAM statements for DynamoDB to sort of only allow specific actions on specific resources, because this is of course pretty wide open right now. Now you can also see that we have this new section that's been added to our YAML file. It's called resources, and then under that we have resource. Now I'm honestly not entirely sure why it's resources.resources. Maybe you can get rid of one. I haven't tried that yet, but you're welcome to try. And then we're pretty much naming our resource. We're going to be calling it users table. And then here we're saying that it's going to be of type DynamoDB. We're going to be we're asking it to provision for us a DynamoDB table. And here we're specifying the properties of what we want this DynamoDB table to have for us. So first of all, we're giving the name. So we're telling it that the name of it is going to be cars table. Then we're specifying the attribute definition. We're basically saying that we're going to have an attribute of ID, which is going to be of type string. So pretty much we're just saying that, you know, because whenever you're specifying a DynamoDB table, you don't have to specify all the attributes of what your table is going to hold. You do just have to specify one attribute, and that attribute is going to be sort of your primary key or your main key within that particular table. So in this case, we're saying that we're going to have an attribute whose name is going to be ID. It's going to be of type string. And then we've got the key schema. The key schema is basically where I'm pretty sure, and you can of course look at this more in the documentation on AWS. I'm just going off of memory here. I think this is where you kind of specify your partition keys, which just kind of helps with indexing. And again, we're just going to be using the same sort of ID, and we're going to say that the key type is going to be of hash. And then finally here, we're just pretty much specifying some throughput provisions, basically how many read capacity units we're going to use and how many write capacity units we're going to use. And over here, we're just going to be using one, because I think here, this is how you can stay within the sort of free tier. And that's actually still gives you quite a lot of read and write units for your just basic, playing around. Okay, so now as it stands, our YAML configuration is basically done. We can now actually start writing the actual code for our REST API. So at this point, this is going to feel a lot like we're simply building a simple Node REST API, which means that we are going to have to install some basic Node REST API things. And that's of course going to include body parser, because we're using Express, which won't know how to parse the body. So let's go ahead and install body parser. We're also going to be installing UID, because we want to basically build up an ID, right? Because the thing is, we're using DynamoDB, which doesn't create an ID for you automatically like a regular SQL table would. So therefore, we have to use UIDs to be able to go ahead and build up an ID for each individual item. And then finally, we're also going to be installing the AWS SDK to actually go ahead and be able to interact with our actual DynamoDB client. So let's go ahead and install those things now. Okay, so here you go. I'm saying yarn add UID, AWS SDK, and body parser. I'm going to hit enter and let that install. Okay, so now that that's done installing, let's start importing and start running the code to get this REST API to work. Okay, so here I am importing body parser, importing AWS SDK. I'm creating a DB instance by calling the AWS DynamoDB document client constructor. And then I'm of course also importing UID. From UID, I'm importing version 4. Let's set up our body parser middleware really quickly. Okay, so here you can see we're basically saying app.use body parser URL encoded, app.use body parser.json. So now body parser can start helping Express go ahead and parse out the body or the information from the body that we're going to be sending down on post requests. So with the sort of boilerplate out of the way, let's start actually writing our endpoints, which is going to be one to create, one to read all the cars, one to delete a car, and then of course one to update a car. So let's start implementing that now. Okay, so here I am. I'm specifying that we're going to have a post request to /cars. It's going to accept an async function. We're going to be building up our params object. So the params is going to include the table name. So this is a very specific syntax that you need for DynamoDB. So it's going to have an object that's going to have at least these two keys: table name uppercase T, item uppercase I. The table name references whatever table name it is that we're trying to go ahead and make the action on, which of course in our case is going to be the cars table. Then we have the item that's going to have these four fields. It's going to have an ID, which is going to be equal to the UID. And then we're going to have a make, which is going to come from data.make, model, and year. And then finally down here we have a simple try catch where we're basically going to say db.put passing in the params, and then we're going to call the .promise method on it, so that instead of us having to use the callback version of this SDK, we can use the promise version, so we can go ahead and await it. And then if it works, we're going to say res.status 201, and then we're going to simply pass back the car that we just created. Otherwise, if it fails, we're going to pass back a 500 saying that the error is equal to e.message, whatever that error might be. Here we're specifying that we're going to have an app.get to /cars, and all we're really doing here is we're once again going to be building up a params object, only this time all we need to do is specify the table name, which is of course once again the cars table. We're going to get the result by saying await db.scan, passing in the params, once again calling the promise method on it so we can get a promise back, and then we're just going to go ahead and say res.status 200, passing back the cars, which is going to be equal to this result of what we're getting back from the db instance. Here we now have the app.patch, which is going to go to /cars/:id. So basically the URL is going to be /cars/some_cars_id. And then we're going to be building up a, once again, so this one is actually going to be very similar to how we're going to be doing it here in the post request. There is a different way of actually updating items in DynamoDB. It gets a little bit more complicated, so I figured for the sake of this video, we're going to keep it in a simple way. The way that it works is when you use DynamoDB's put method, you can either create a brand new item, or alternatively, if the DynamoDB recognizes that the ID is the same as an item that already exists in the database, it'll just go ahead and make the changes on whatever fields are different. So that's exactly what we're doing here. We're pretty much just going to be building up another object exactly as we did before, only this time the ID, instead of it being a new UID, is going to be equal to the ID that we're getting from the body. Or alternatively, we could also have been reading it out from the params that we're getting from the ID. Either way is fine. And then basically we're once again going to go ahead and call the put method, passing in the params, getting the promise, and then we're just simply going to go back and turn back a 200 with a newly updated car. Finally, we're now specifying the last endpoint, and that's going to be an app.delete, once again going to /cars/car_id, and then here we're going to be building up the params object, which is going to be including a table name, and then this time we're going to be including a key, which is in itself going to be an object, and the key in this case is going to be the same ID, which is the sort of unique identifier for each one of our records in our table, and then we're going to be getting that ID from rec.params.id, which is specifying, which is pretty much referencing this ID that we have from the :ID. And then we're just going to go ahead and call the delete, passing the promise, passing in the params, getting the promise, returning a 200, saying that success was true. We have successfully deleted the item. And that is pretty much all the code that we need in order to kind of get this REST API to work. So now let's deploy this again and see that we can actually run this all in Postman and see that it all works correctly. So we're going to say SLS deploy, wait for this to be done. When it is done, I'll come back. Okay, so now that this is done deploying, we now can grab this URL. So once again, we have any endpoint will work. This is, or any method rather. And then we can grab the endpoint, we can head on over to Postman and start checking to see whether or not we can go ahead and go through all the CRUD operations and see if our REST API is actually working. So let's try that now. Okay, so here we are now in Postman. As you can see, I'm specifying a post request to our URL to /dev/cars. I'm saying that we're going to be passing any body. I'm choosing the raw option here, saying that we're going to be passing in the body as JSON. Let's go ahead and specify our car. Okay, so as you can see, I'm creating this object here. I'm saying that we're going to have the make, which will be equal to Honda. Model will be an Accord. The year will be 2018. Let's go ahead and hit send. Come on down to the response, and as you can see, we do in fact have a car, and we have this ID which was created by the UID, and then we have the make, the model, and the year. So far we've actually been able to successfully create a car. Okay, so as you can see, I've now made a get request to /cars, and now you can see I'm actually getting back cars, and then the items. In this case, of course, I only have the one car. So now let's actually try to edit the car, and then finally we're going to go ahead and try to delete the car. So let's change this to be a patch. We're going to go to /cars/this here ID. Now let's go ahead and specify the body. Body be raw, JSON. So we're going to take the exact same car again. We're just going to be passing in the ID this time, and then the ID be equal to what we currently have in a clipboard. And now instead of saying that we're passing in a Civic or an Accord, we're going to be passing in a Civic. Hit send, and there it is. Now the car is not a Honda Accord, but now it's actually a Honda Civic. Finally, let's go ahead and delete this car. Let's get rid of the body. We don't need the body because all we have here is just going to be the actual ID in the params. Hit send, and then we get success true, which means if we now go back to making a get request to just /cars, we should of course get back the items should be equal to an empty array. So let's see if that in fact happens, and there you go. Cars items is in fact an empty array. So that pretty much is our REST API. One more thing I do want to point out, which would be very helpful when you try to develop your own serverless REST API locally, and that's going to be how to actually run this code locally. Because as it is right now, every single time we wanted to test it, we had to actually go deploy it and then use the live URL that we get from API Gateway. But as it turns out, there is actually a way to use localhost. So let me show you that right now. Okay, so in order to be able to run this against localhost for your local development, what you're going to want to do is first of all install something called Serverless Offline. So we're going to say yarn add serverless -offline. Install that. Now, once that's done installing, you can go on over to your serverless.yaml file, create a new section down here. We're going to be calling this plugins. As you can see, we now have a new section down in our serverless YAML file called plugins, and we're referencing the serverless offline module that we just installed. So now what we can do is, instead of actually trying to run SLS deploy and then using the actual live URL, what we can very simply do is say SLS offline. And now the project is actually running on localhost 3000, so we can actually once again go ahead and reference this. So let's just make a simple GET request and see that we can still access our actual DynamoDB table using this localhost 3000 URL. So let's see if this works. Okay, so as you can see, we now have a GET request going on to localhost 3000/dev/cars. Let's run this. And we do in fact get a response again. Of course, it's currently empty because we just deleted the one and only car that we have, but as you can see, it is in fact working. Now, the last thing to point out is once you're done and you no longer want to have the service up, you're afraid you might get billed or whatever it is, you're done developing, you're done playing around with it, you want to get rid of it all. Last thing to do is you can just come on back to your terminal, you can say SLS remove, and then it's going to remove your stack with whatever services this implemented. That means whatever databases, whatever API gateways, whatever functions it created for you on behalf of you in the cloud, it's going to go ahead and remove all of that, and then it's all clear. Okay, and as you can see, it is now telling us that the stack removal is finished. We now have no resources that have been provisioned on behalf of us in our AWS cloud account, and we're done. Well, that does it for this video. Hope you enjoyed it. I hope you found it useful. If you did, please drop a like, subscribe, and I'll see you next week in another video.
Perfect.